chapter 6. And chapter 6 is all about aerobic cellular respiration. So you've done the test on, not the test, but you've done worksheets talking about cellular respiration and talking about photosynthesis and the difference between the two. So, of course, we're talking about how all of our organisms get their energy and they're get it to form what we call ATP. And so aerobic respiration, you have an overview of it and you want to take a look at this overview. Oxygen, of course, because it's aerobic, air has oxygen in it, so it's used to oxidize glucose. Glucose forms carbon dioxide. Oxygen is reduced to water. During the whole process, you get NAD and FAD. And they go through the glycolysis and Krebs cycle. I am sorry, but I did not intend for this to come up. Okay. And then the electrons pass through the electron transport chain, and that goes on to make energy for ATP. Now, I did talk about this before, and so just remember from chapter 5, we talked about ATP being the main energy for the cell, and that the most ATPs are made during the electron transport. So this just shows the process for aerobic respiration, but I wanted to go ahead and start at the beginning of aerobic respiration, which is glycolysis. And so you need to know what glycolysis is, that it happens in the cytoplasm. It's the only part of aerobic respiration that happens in the cytoplasm. It makes 2 ATP molecules, or a net of 2 ATP molecules. And it is the only one that's anaerobic. So all the other parts of the aerobic respiration are going to require oxygen, but this is the only one done the cytoplasm, and this considered to be anaerobic. You don't have to know the details of glycolysis because you are not biochemists, and so I won't ask you any of those details. We will move on though to the second step in aerobic respiration, which is the Krebs cycle. The Krebs cycle, also known as citric acid or tricarboxylic acid cycle. So just knowing that when you hear either of those names, that they're talking about the Krebs cycle. And this is where we break down pyruvic acid. But what is important here is that this is the first time that the process occurs in the mitochondrial, and it occurs in the matrix of the mitochondria. So we just said that glycolysis happened in the cytoplasm, but this one actually happens in the mitochondria. And then the electron transport chain, of course, again, this is where the most ATPs are made. I can't say it enough. I can't explain to you enough to make sure you understand that this is where it happens. And it all happens, all these ATP are made because of these NADH and FADHs that you've made during the glycolysis and Krebs. They go to the ETS, and they are what create the most ATPs that are made. And so another key factor to note is that oxygen is the final electron acceptor. That is very important. The enzyme that's used here is the ATP synthase, and that is what allows ATPs to be formed. So note the total yield of ATPs for aerobic cellular respiration. Glycolysis, you make 2. Krebs, you make 2. And then in the electron transport, you make a total of 34. And that gives us a total of 36 ATPs. So 34 in the electron transport chain, 32 in the electron transport chain, 2 in the Krebs, making it 34, and 2 in glycolysis, making it 36. So as it shows here, you get 24 ATPs in the electron transport chain from NADH. You get 8 from FADH, and 8 in 24, of course, is 32. And then you get 2 out of Krebs and 2 out of glycolysis. I'm pointing it out for a reason. And so please take note of how many ATPs that you make in each stage of aerobic cellular respiration. They talk about respiration in prokaryotes. I'm not sure if I asked you questions about it, but I do talk about on the test metabolizing glucose in the absence of oxygen is anaerobic respiration, and it happens in a process called fermentation. And so you need to understand that fermentation reaction oxidizes NADH that is needed, and that you end up making 2 ATPs out of it. So fermentation, alcoholic fermentation, this is how we make alcohol, grapes, yeast for beer, bread, all of those. You make 2 ATPs. You go through lactic acid fermentation. No carbon dioxide is released, but the pyruvic acid turns to lactic acid. And so this is what happens when your muscles cramp and become very sore after you've been running. If you haven't got enough oxygen, lactic acid builds up, and it's what, as they say, creates the burn in muscle. So I always think that that's a pretty key factor for people to know. Don't quite realize it. Remember, if I do test you on it. But knowing that you can make ATP without oxygen, and that's going through the process of fermentation or the lactic acid process. Next, you just need to know that you can make glycolysis in other ways, or glucose in other ways, by metabolizing your carbohydrates, your fats, and your proteins. And so you remember those are macromolecules, and that they are polymers that can be broken down into monomers. And so this just shows that you can take fat respiration, and each molecule of fat fuels the formation of many ATPs, and you can convert fatty acids into acetyl-CoA, and they can enter the Krebs cycle and end up making ATPs. This is what happens when people do a low-carb diet. Their fat will then begin to give them the energy they need, and so it starts being used up, which is why Atkins works a lot. Protein respiration, when your proteins are digested into amino acid, they generate keto acids, pyruvic acid, and those enter the Krebs cycle as well. And then carbohydrates, of course, are broken down into glucose, and it enters the glycolysis and moves on into the Krebs cycle. And so, bottom line, carbs, fats, and proteins can also be used for energy, which is why we eat food. The more calories are consumed than used, the excess will be stored and then used later. And so, now you know all the things that are important for Chapter 6, focusing mainly on the 3 components of aerobic cellular respiration, knowing that because it's aerobic, it needs oxygen, that you're doing the whole thing to make ATP, and that there are 3 steps: glycolysis, Krebs, and the ETS. ETS is where you make the most. 32 ATPs are made there, 2 in Krebs and 2 in glycolysis. And then you also can do fermentation or make alpha alcohol, lactic acid, and you can take your fats, carbs, and proteins and also get energy. All right, so that should help in terms of solidifying Chapter 6. All right, so as soon as I get this up, we